40 something on this thing, you would have been in our top, maybe number one in our top 4 for sure. But this is, actually, I think I have a copy. This is state test D. All right, so state test D, real quickly. I'll just run through the answers if you want to look at your key. Hopefully you spend at least a little time on this so we don't completely waste the day, but it is what it is. I think we're all maybe a little burnt out on all this after a week and a half. I totally get it. 1 is D, 2 is A, 3 is E, 4 is D, 5 is A, 6 is C, 7 is D, 8 is A, 9 is C, 10 is C, 11 is B, 12 is B, 13 is A, 14 is D, 15 is C, 16 is A, 17 is C, 18 is C, 19 is D, 20 is A, 21 is A, 22 is B, 23 is B, 24 is E, 25 is B, 26 is D, 27 is B, 28 is -4, whatever that letter is. Anybody? E? Oh, B. So 28 is B, 29 is A, 30 is C, 31 is D, 32 is B, 33 is A, 34 is B, 35 is C, 36 is C, 37 is E, 38 is B, 39 is A, 40 is D, 41 is B, 42 is C, 43 is B, 44 is B, 45 is C, 46 is D, 47 is B, 48 is B, 49 is D, and 50 is B. So, you got a question on something? Curious as to how it works out? Holla at me and we'll take a look. $40. So number 40. Let's see. Wow. Ugh. So number 40 said, let A be the origin, let B be the 0.14, C be that, D be that, and E be that, be the vertices of triangles ABC and ADE. What is the relationship between them? In my notes, I basically found the 3 sides. I guess first I looked at the answers. I looked at the answers and tried to see, what are they asking me? Like, are they just congruent? Are they proportional and congruent but not equal? Are they equal? So I went in there and I thought, well, let me just find the lengths of the sides and see what happens. So I took the A, B, and the C and found the lengths of the sides and found that they were 3, 4, 5 triangles. That was a 3, 4, 5. And then I did the same thing with ADE, but I found that that was really ugly. Like the sides were root 17 And you can see when my work, I have like root 9 plus 9/16, which probably simplifies, but I haven't bothered to do the math. And then I have root 4 3/4 squared plus 4. But I went ahead and plugged that into the Pythagorean theorem and checked, and it also was true. So it is also a right triangle. And then I checked some proportions. Like once I kind of understood the small leg, big leg, and hypotenuse, what they were, I checked the proportions to them. And when I looked at the proportions, they were actually equal. You can kind of see me doing that. I just picked the short side, the short leg and the big leg, and then on AC and AB, granted, I had to find AC, AB, and BC and simplify them into fractions, or square roots of fractions, so that I could see which one was bigger or which one was smaller. So I determined, if I'm looking at AC, you can see where I found that was the square root of 153/16. That's going to be smaller than the root 17, just because that fraction is smaller. You can just kind of eyeball it and see that it's around 8-ish or so, 9-ish. So I put the AC over the AB, which again, it's ugly, but to divide, I multiply by reciprocal, start canceling stuff, and I can see that they actually are proportional. So I said, well, they're proportional, but they're not equal. They're not the same. So that's why I went with the little squiggle line. Anyway, kind of ugly algebra. Just done through trig and algebra, which is normally where it comes from, or calculus. But anyway, that was just me trying to play around. I didn't draw a lot of pictures and stuff on that one, but what else? Sorry? 5. So on number 5, all right, it says, your teacher gives you 5-question multiple choice quiz. Each question has 4 answer choices. You forgot to study and are going to have to guess at random. What's the probability you get an 80 or better? Okay, so I looked at that and I said, well, 80 or better means 4 out of 5, right? Which would be an 80, or a 5 out of 5. So I basically said, what's the probability of getting 4 correct and 1 wrong, or all 5 correct? Well, if the probability of getting one thing correct is what? On a 4 answer choices, what's the probability of getting 1 correct? 1 in 4? So I said, why don't I have this up? Sorry. It'll come up in a second. So if you look at my work, you can see it says probability of getting 80% or better, which is 4 or 5 correct. I did 1/4 to the 4th. That's correct 4 times. And then 3/4 to the 1st. But remember, it doesn't have to happen in that order, right? It doesn't have to be correct, 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 wrong. It could be wrong, correct, 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 or correct, wrong. So I have to count those. So 4 factorial over 3 factorial, 1 factorial. And then, 5 factorial over 4 factorial, 1 factorial. And then the probability of all being right is just 1/4 to the 5th. I put 3/4 to the 0, but that's not necessary. And I don't even need the factorial because everything cancels on that one if it's all one choice. And then I just crunched the numbers and got 15 over 1024 plus 1 over 1024. And then that simplified a bunch. Hopefully you didn't actually divide. You looked at that and got 16 is 2 to the 4th, 1024 is 2 to the 10th. A bunch of those 2's cancel and you end up with 2 to the 6th on the bottom. So 164. But that's certainly something that we can get if you were just randomly guessing. So not a good chance of getting an A or a B for this guy. What else? What else you got?
In number 11, what is multiplicity? 6.
Multiplicity means how many times it's going to happen. So like if you have a double root, that's multiplicity of 2. If you have a triple root, multiplicity of 3. But what do you say if you have a root that happens 6 times? Right? There's not a nice word like double, triple, quadruple, quintuple, septuple root, or septuple root, or septuple. I forget. But anyway, that they'll just say a multiplicity of 6 means there's 6 of that identical root. 9. So number 9 asks, for how many integers from 1 to 100 is x squared plus x cubed equal to the square of an integer? Okay, so I guess you could just do a lot of guessing and checking, but what I did was this. I thought, well, if an expression is going to be a square of an integer, that means it's a perfect square, right? So I thought, well, if I factored that, I'd pull out an x squared. And if I pull out an x squared, I know that's always a perfect square because it literally is something squared. So now all I have to do is make sure that's a perfect square. Well, of all the numbers 1 through, what did it say, 0, 1? Of all the numbers 1 through 100, there are only a certain number of perfect squares, right? So if I think about all the numbers that are perfect squares, I could get a perfect square if this was 4, which would mean x would be 3. I can make that a perfect square when it's 9, which means x would be 8. I can get a perfect square when that's 16, which means x is 15. So I just went through there and said, okay, how many different x's would make that a perfect square? Now remember, I can't use like 0 in there because even though 0 technically is a perfect square, it's not in between 1 and 99. So I had to make sure I'm a 1 and 100. I had to make sure I ended up 1 to 100. So I just had those are the only numbers that I could add to 1 and get a perfect square. And again, I know that part's already a perfect square. So that made it a little easier for me to think about factoring that. Otherwise, I'm literally just plugging every single one of the 99 numbers in there, which is awful. So this way it just made it, I could just think, oh, only this is already working. I just got to make sure that works. To me, that was easier to think through. But again, I don't know where that falls in pre-cal or whatever, but again, this is comprehensive. They can just throw anything out there. What else you got? All right, so in 28, they asked, that was 28. Let's see, 28, they asked, all right, find the product of the solutions of that equation. So the product of the solutions of this. I have a feeling, I'm going to look at this. I kind of remember doing this, and if my memory holds, it was just atrocious. Yeah, it's atrocious. Yeah, this is just an awful question, I thought. And I remember getting it and going, I guess through some experience of mine doing 5,000 math tests, I've noticed things like 4 minus root 15 and 1 over 4 plus root 15 happen to be equal to each other. And I know that only because when I square that, I get a 16, and I square that, I get a 15. So if I multiply by a conjugate, I get 16, if I multiply by 4 minus root 15, I get 16 minus 15 on the bottom, which is 1. And I would only have left the 4 minus root 15 on the top. And that's true when that perfect square, that square of that and the square of that give me 1. That's just true. And I've noticed that. So I said, well, if that's equal to that and that's equal to that, then couldn't I argue that if u equals this, then u to the negative 1 equals that? So what I did is I replaced those two values with u and u to the negative 1, which again is a huge stretch on your ability to process and think. And if that's true, what I did was multiply by u to the x. This is basically a 1 over u to the x, which I just said, okay, if that's a 1 over u to the x, I'm going to multiply through by u to the x to get rid of that 1 over u to the x. Does that make sense? Like you always do when you have a variable on the bottom. You multiply through by it. And that gave me this, which I could get on one side and go away. Now I could treat this like a u to the x squared and a u to the x. I could make a substitution. I could call that a squared minus 8a plus 1. So I'd basically be solving for a. So I solved for a, except I didn't bother to make a substitution. I just recognized that would have been my a, the u to the x. So I solved and got that answer right there. Again, this is horrible. And some kid got this. That's just amazing to me. I think I spent, I can't tell you how much time playing with this number on a Sunday afternoon trying to figure it out. So I ended up factoring that and getting this. And I said, okay, if u to the x is that, then that means on both of these right here, I said, and if u to the negative 1, which remember was my original substitution up here, u was this and u to the negative 1 is that, then what I did, I squared both sides of this to get that. And then once I got that, oh yeah, since now these two are equal, u to the x and u to the negative 2, I said u to the x and u to the negative 2 equal to each other, which gave me negative 2. And I did the same thing here. If u is that, but wait, u is also this. If I square that, I get this, and now u to the x and u squared are equal. So u to the x equals u squared. That was one of the harder questions I think I've ever done on a state test. I don't know how somebody's getting that. It's just pretty awful. And I'm not kidding when I tell you, I didn't know how to do it, and then I didn't know how to do it. And then I quit. I came back and looked at it, and then I noticed that little substitution at the beginning. I was like, oh, wait a minute, I could maybe get somewhere. But in a million years, I wouldn't have gotten that in a 2-hour window. So if you assume the position, I grant you clemency. It is a very assumable problem, even when we don't assume the position. What else? 19? Yeah, that's just dirty. Seems to me like I emailed her about that too and said, is there a better way to do that? No, I think I just said, hey, how did you do that? And she sent back a solution, and it was this with the same substitutions. It's like, but this was like their 4th year doing it. I think sometimes their years are hard to know. You said 19? All right, 19. All right, so I may have used calculus here. Let me see if I can come up with a better way off the top of my head real quickly. Let me see. So 19, what is the minimum value of that on its domain? Yeah, in calculus, when you're trying to max and min something, you take a derivative of it to find its slope, set the slope equal to 0, and you solve. And why that works, when slopes are 0, that tells you where a graph hits its maximum or when a graph hits its minimum. So if you can find out the x values of where the slope is 0, you're home free. Problem is you don't know how to do a derivative. You'll probably learn enough to do this probably by Tuesday or Wednesday of next week. But you'll not, we won't even get into the application of this. But that's basically what I did. I solved for the x, and then I just plugged the x back in to find out what that y value was at that space. Now, the only other thing I could think to do on this is to maybe treat it like a parabola. So if you think about this problem, because it is, well, it's kind of parabolic looking. I'm going to be honest with you, I don't have a lot of confidence that this will work. But if I said, if I look at this as a parabola, you know, it kind of looks quadratic looking, right? Because this squared gives me this. If I said negative b over twice the a is the root x, actually it does work. Do you remember that little shortcut for finding the x coordinate of a vertex? Where you go negative b over 2a? Y'all vaguely remember that? Someone getting some yeses? Well, look, negative b over 2a gives me this, but I would be solving for root x, because right, root x squared. And if I square both sides, I get the x coordinate of my vertex. But I only can do that if I recognize that it's parabolic. What it is kind of quadratic in nature. So if I did that, I'd have the 9/4, And then I could just go back up to the original function and plug 946. So if you ever are asked about a max or a min and it looks quadratic in nature, do the negative b over 2a thing. But remember, you're solving for whatever that middle term is. Because like on a quadratic, if this was quadratic, you'd be solving for x. Well, if it's quadratic-like, you're solving for whatever that is. So complete the solve. That's the x-coordinate of my vertex, kind of, sort of. So you plug that back into the original function, and that would find the y-coordinate of your vertex. And we know that a max and a min is always just the y-coordinate. It's not the vertex. It's the y-coordinate of the vertex. So that would be another way to do it, but I don't, yeah, I mean, it would not have worked in any other way. But I got to be honest with you, on the test that we've seen, that's the second time I've seen that. Although it might have been on an Algebra 2 test. But when you're doing maxes and mins, they're always quadratics at this, well, no, they're not. They're normally quadratics at this level because a lot of people aren't in calculus, so they kind of throw you back to work where you could still get there. And you can complete the square, but I mean, most people aren't really thinking with x minus 3 root x plus something. They're not really thinking parabola, but it's because it's quadratic-like. What else? Well, I guess that's something that you could probably pull off. Anybody? Anybody?
You need 21.
Probably. So 21 said how many integers are in the solution set of that inequality. So, so I wrote down the equation. I didn't like the x on the bottom, so I multiplied both sides by an x to cancel it. Didn't do anything to the right, but got me this. Problem is, when I multiply by an x, what happens to the inequality? Does it stay the same? Does it change? Well, it would depend on x, wouldn't it? So that's when we go, all right, inequalities, if I ever have an inequality, right, and it's got a denominator, then give up trying to maintain what that sign is and just start solving for critical numbers, and then you're going to check between them. So the first thing I noticed is if I have an x on the bottom, x can't be 0. So that's going to be a point on my number line. I can go ahead and mark 0, and it's not true, so I can't include it. And then at this point, I still have another x on the bottom, but I have no idea whether it's greater than or less than. I know it's not equal because there's no equal sign, so I went ahead and said, okay, from here on out, all I'm doing is finding where it's not equal. So I multiplied by x again and got this canceled there. I got to remember to distribute that negative in later. Distributed the negative in. Okay, it's not even a quadrant. What's kind of a quadrant? That solves to give me this. I add the 19 over and I get a root 19, which I don't know, 4.5-ish, but it's plus or minus. So I marked those. And once I had marked both of those, I just started checking. And the question was, how many integers are on this? Now, it could be infinitely many, and it could be just some finite number. So I looked at it, and I checked the left side of that, and I got not true. And again, if you're wondering what I checked, root 19 is like 4.5, so I probably checked -5 in the original problem. And it was a not true statement. So I'm not shading there. And then I went over here and checked +5, and it was also not true. So at that point, I know it's not infinitely many. Okay? So then I came in here and I checked something probably like -1 and +1, and it was true. So because this part was shaded, I just went in there and counted up how many integers are in there. And the integers were those 4 and those 4. So there ended up being 8 solutions. 8 integral solutions. But anytime you have an inequality, anytime, you're going to be putting stuff on a number line. And anytime you have an inequality with the denominator, you got to remember to include that denominator in the undefined. Any denominator. If it has multiple denominators, include all those values that you get for those undefined spots on your number line as open circles. And the only closed circles you have is if this was less than or equal or greater than or equal. Right? We can get that. I mean, that's a problem we know enough to do if we just remember that about the number line. But I remember y'all's test, a lot of people in this class and the other class, and in every class, they just forget the number line. They just assume not equal, and they get down and they have this inequality, but the inequality is really not there anymore because you don't know whether that's positive or negative. You don't know where to keep it or change it. Could be either one. Could be both. It is both. That's what you have to figure out by checking. What else you got? Anything else on these? Come on, guys. There are a couple of y'all when I check it, you're like, you are remarkably good about, like I'll look at, like when I do your little answer documents that you filled out, like all the ones you wrote down, you were right on. You skipped all the other ones. But most people have some right, some blank, and they've missed some. So I know you got some misses. Come on. Unless you totally did nothing. 48. So what is the slope of the line which connects the center of that circle and the vertex of the parabola? So obviously the center is pretty easy to find, right? That's just 4, -1, because it's already in that form. And got to be honest with you, I'm surprised it is. I'm shocked they didn't make you complete the square on that. And then I got to find the vertex of the parabola. What are 2 ways to find the vertex? You could either do completing the square where I add the 5 and then factor the 3 out of this, which leaves me 3x squared minus 2x. And then I complete the square by taking half of that and squaring it. So I added 1 to that side, but I don't add 1 to this side. I add 1 times 3 to that side, which gives me this, which the vertex would be 1, 2. But the other way is to go -b, which gives me 6, divided by twice a, which is 6. 6 over 6 is 1. And then take a 1 and plug a 1 there and a 1 there, and I get 8 minus 6 is 2. So that might be a little easier to do if you remember that -b over 2a that we were just talking about. And then all I got to do now is find the slope between these two. 8. What else you got? Oh, and let that be a lesson that the last few numbers are not always the hardest ones. All right, I've been seeing that over and over on these tests. Like number 50 was pretty doable. 48 will be pretty doable. So if you're just plugging straight through, that's not always the best plan, but do the best you can. What else? Number 1. Yeah, they love to start number 1 off with, let's just throw some basic math at them and see if they can crunch and not make a careless error. So I looked at that and I was like, well, what does 81 to the 3/4 mean? When I'm doing fractional exponents, I always start with the denominator because the denominator is a radical, and that usually makes my number shrink really small, makes it doable. I certainly don't want to cube it first. Then I get a zillion huge number that I have to 4 through. So 4 through of 81 is 3, 3 cubed, 27. Now I'm here. Here, square root, I do that first, of 9/25 is 3/5. 3/5 to the -3. What do I do with that? Cube them both and flip them. So I cube it, and I get 27 over 125, and then I flip it. Over here, that to the 0 is 1. That to the -1/7 is 7. And then again, that to the 3/4 is the 4th root of 625, which is 5. And then 5 cubed is 125. And at this point, those two numbers cancel, and I get 125 plus 7 times 125. And rather than actually do that math, I'm seeing that I'm about to have to cube root this guy. So I thought, wait a minute, why not keep it factored? If I have 1 125 and 7 125s, I have 8 125s. And cube rooting 8 125 and 8 would be a lot easier than actually having, no, it wouldn't. If I multiply it together, I get 1,000. Cube root 1,000 is still 10. But either way, I left it like that, so I didn't have to bother with the multiplying. But anyway, 2, 5 is 10 to the -1, and I flip it. So just a lot of tedious algebra, a lot of tedious algebra 2 on that. But you really need to get, we do this in calculus all the time, you really need to be confident on those fractional exponents. Do the root part first, then cube it. That's almost always a better plan. 6 said, what is the shortest distance from that point to the circle? So the shortest distance from a point to a circle would be on the line with the radius, right? I'm sorry, on the line with the center, but then out here. So to do that, it's really hard to find a point on the circle that you know is in between those two. So what I did is I just found from the point to the center, and then I got rid of the radius. And on number 6, I already have it in the right form. So the point is -2, 3. The point on the circle is 2, -5. So I just did x minus x, y minus y. I squared the differences, added them together, and square rooted it, and got root 80. And then I got rid of the radius, and the radius wasn't 5. Remember, if the circle's equal to 5, the radius is root 5. So I got rid of the root 5 part to get rid of that radius. So I would have just that distance right there. And because that happens to be 4 root 5, I can subtract the root 5 pretty nicely and get 3 root 5. And a lot of times they'll ask you for that, and sometimes they'll ask you for the distance to the place where it's tangent. What do you do if I ask you from a point to where it's tangent? Tangent would be like right there. Are you with me? How can I do that? How do I find that distance? This is actually a much more common question. What do I know? I can draw a triangle out of this, right? Because if it's tangent, what do you know about this radius? Are y'all seeing that? So if that's the case, I know the radius is root 5. I already found this total. The total was 4 root 5. And you have a Pythagorean identity you can use. That's a much more common question than even this one or number 48 where they said point to a vertex or something like that. And AP Cal loves the tangent line, man. They will tangent line you to death. I bet on any one test they're going to ask you about some kind of tangent line approximation or tangent line or what is at least 4 times. I mean, I'm not kidding. It's like 1/17th of the test. I mean, it's all over it. Examples of how you'll use it. And it's kind of cool. Like you can use a tangent line to approximate square roots. Like I could have, without a calculator, not that this is like scintillatingly informative, but like I could find the square root of 24 accurate to like 3 or 4 decimal places using a tangent line approximation. So there are some applications without a calculator, which used to be nice because we didn't used to have calculators until the early 70s. And even then they were like we were not rich, but my dad was kind of an engineering military guy. He spent $100 in 1976 on a calculator that added, subtracted, multiplied, divided, took a square root. That's it. Oh yeah, our first house was like 22 grand in Washington, D.C. I mean, it was like super nothing. A bike was like $30. You know, pair of Nikes, $16. Nice leather ones. I mean, $100. We were like, Dad, it's crazy. Had the little red LED readouts, the little lights. I don't even know if you've even seen stuff like that, but it's like the old digital watches. Whatever. It's just like literally little red lights. And if a light went out, you're like, crap. Now my 8 looks like a 6. I took like 6 batteries. It's like this big. It's huge. Texas Instruments. What else?
49.
49. And that will probably wrap it up. How many ordered pairs where x and y are both integers satisfy this equation? So what did I do on this? Looks like I just started guessing, checking, and revising. So I just started looking at random numbers, plugging them in there to see what happened. I can tell you if it ends in a 4, there's probably going to be a nice little relationship between your X and Y that would have a common denominator that would reduce to a 4. So using numbers like 7 are probably a little less likely, but I just started guessing and checking. There's probably some math counts little trick or formula that like Brandon knows from doing that back in Florida. There's probably some little rule or trick to that, but I've never learned it. But I just did that, started guessing and checking random numbers. And every time I found one, I realized it didn't really matter if I switched the numbers, so I double counted them all. And I happened to be right, so I smiled and moved on to number 50. All right, guys, we will see you bright and early. Please, if you're getting a ride from somebody else and they tend to be late or unreliable, like my mother was, please find a better ride or lie to them and tell them you'll be there at 8:15. Yes? Oh, just stretch them. And we will see you there. If the front door's not, back door's not open, try the front. I know they're doing Saturday school, so doors should be open. But I will, when I come in, I'll try to leave them ajar and just cruise on down. And our tests are white, so I have a feeling I'm going to put the tests face down on the tables. You with me? So I'm going to put them face down. Just go and find a test that's face down, that's white, and sit at that place, because I'll probably have you at a table with an algebra 2 and a geometry person, or unless it's a really small place, then I'll have you all sitting. I'll have you sitting maybe with just one other person, maybe even just about you by yourself. But just find a white, don't flip it over, and then I'll pass out your Scantrons, and then in an hour and 10, and then just like take a nap or whatever, but I will be watching you. So please try your best for 2 hours. And then this may be it. Yeah. We don't have a lot of seniors help us. I think this year we have 3. We had 5, but one got coronavirus, which is unfortunate. He was one of our top 4 last year, and one had some activity they couldn't go. We still got 3 of our top 4 returners, and plus some of you guys have really done well. I think I like our chances. We'll see what happens.
Well, we can come back soon.
All right, guys, y'all have a good one. See you tomorrow. Yeah, absolutely. Nice, excellent choice.
Thank you.
Have fun.
Where are you going?
for